So in signature file, the first thing is we have to identify the words. That means index terms, content bearing terms for representing every document. But rather than using each words individually, we have to use a group of words together. That means we have to create within the text content a block that contains multiple words. As much as possible, we have to create a block with equal number of words. So in our case, after removing stop words, normalizing and stemming, you will get equal number of words in each block, 2. Text and the money in the first block, word and the word in the second block, made and the letters in the third block. Now, once we form a block of words, the next step is we have to create a word signature based on which to create a block signature. Then at the end of the day, those block signatures are used for representing the document signature. How to find first the word signature. Every words are combined from different characters, and we can use the position of every characters alphabetically. Like in English, A to Z. We can start from A1 up to Z26. Accordingly, A, B, C, D, F, G. So A takes 1, B takes 2, C takes 3. In such a way, we can take into account the position of every character in a given writing system. So in English, since we are dealing with small letters, A is at the first position, B second position, C third position, D fourth position. So then the last Z is at the 26th position. So we can use this positional information for hashing every words. Like the first word is text. Text is containing T, E, X, T. Then add the position of T plus E plus X plus T. Then convert it into binary form. For converting, it's simple. Just divide by 2 to get zeros and ones. Sum over all the characters in a given word, then find the binary form of that word by dividing the total positional information by 2. So when we take text, add the position of T plus E plus X plus T. The position of T is at the 20s. The position of E is at the 5th. And the position of X is at the 24th. Then again T is at 20. So that means T20 plus E5 plus X24 plus 20 gives us 69. Now convert it into binary form. That means divide it by 2. When we are dividing 16 by 2, 1 is left. We have 34. And then 34 divided by 2, 17 with a remainder of 0. 17 divided by 2, 8 with a remainder of 1. Divide A by 2, 4 with a remainder of 0. Again divide 4 by 2, 2 with a remainder of 0. Then 2 divided by 2, 0 and with a remainder of 1. Then when we are reading upward, 1 0 0 0 1 0 1 is a signature of text. We can calculate for money. That means M plus A plus N plus Y. Then we have to refer to our positional information in the writing system A to Z. Then M is at the 13th position. Let's take the ones that I already calculated for word. If you take word, it's formed by WORD. So then WORD, W is at the 23 position, plus O at the 15th position, plus R at the 18th position, then D at the 4th position. The sum is 23 plus 15 plus 18 plus 4 is 60. Then if you find the word signature in binary form, 16 divided by 2, 13 with a remainder of 0, 13 divided by 2, 15 with a remainder of 0, 15 divided by 2, 7 with a remainder of 1, 7 divided by 3, 2 with a remainder of 1, then 3 divided by 2, 1 with remainder of 1. That means the signature of word is 11110. Now, once we get the signature of every word, text has a signature of 1000101, many has the signature of 0110101. The same thing for all the words that we have in each block. Then, to find the signature of the block, we have to find OR of every word signature. In this case, in the first block, we have text and the money. And the signature of text is 100101. And the signature of money is 0110101. What is the signature of the block? By ORing 100101 with 0110101. In the case of OR, you will get 0 if both of them are 0. Otherwise, the result is 1. 1 or 1 is 0, 0 or 0 is 0, 1 or 1 is 0, 0 or 0 is 0, 0, 1 is 1, 0, 1 is 1, 1, 0 is 1. So the signature of the first block by ORing text with money is 1110101. What about word? Both of them are word. So ORing 0111 over 00 over 1, the same thing is the same result. That means we are using 011100 as a block signature for a block containing word and word. Then the third block is containing made and letter. Take made. Made is with 00101111. Letter is 1001011. If you OR it, if you OR 0010111 with 1001011, 1 or 1 is 1, 1 or 1 is 1, 1 or 0 is 1, 0 or 1 is 1, 1 or 0 is 1, 0, 0 is 1, 0, and 011 is 1. So the signature is 1011111. We have to make sure that all have equal length or size. In our case, the first one is 1, 2, 3, 4, 5, 6, 7 digit. So this one should also be with 7 digit. If it completes with 6 digit, to the left direction, we have to add 0. By adding 0, we are not affecting the value. That's why here, after calculating for money, we added 0. Why? Because all should have equal lengths. That means with a length of 7 in this case. Once we represent every block with the block signature, which is calculated by hashing every word in that block and by ORing the binary form representing every block in that every word is in that given block. So then we are using for searching the block signatures. If the query word is similar with one of the block signature, given a query, If the query signature is similar with one of the block signature, that means that document is containing the query. How can we know whether the document is containing the query or not? We are comparing the query signature with the block signature. When we are comparing the two, we are ending them. Because when we are ending, at the end of the day, if you are getting the query signature itself, that means what? The block is containing the query. If it's different from when we are ending the query with the block signature, if the result is different, that means the block is not containing the query. So that means, first of all, given a query, like for instance, the query given is text money. If a text money is given, then first of all, if our query is constructed based on many text, then we have to find the signature of money in our query, the signature of text in our query, then OR them to form the query signature. Then after forming the query signature, we have to compare with the block signature. So text money signature is 1110101. So our query is getting 1110101. If you end it with 110101, the result we get is what? The query signature, because they are containing the same words in that block. But if you compare that signature with the second block, our second block is with 011100. Our query signature is with 1110101. So if you are ending them, the result is what? The result is a signature different from the query signature. That means the query doesn't exist in the second block and in the third block. But since the first block is containing the query terms, since at the end of the day, what's returned is similar with the query, then we can say that the document in general is relevant for the query. But sometimes this principle doesn't work. Nowadays, why signature file is not given much emphasis during creating an index file is because it may return sometimes a document which doesn't contain the query. Because the query at the end of the day is represented by signature 0101. Sometimes a block is containing different words, but when we are hashing it, the result may be similar with the query. In such a case, when you are comparing the query signature with the block signature, they may give you the query signature, which means that the document is relevant. But actually, it's not relevant, which we call it false positive. Or the document is not relevant, but actually when we are comparing, it becomes more relevant. Nowadays, the signature file is mostly used in multimedia, like image, video, audio indexing. Because since image, audio, and the videos are represented by pixel level binary numbers, which can come from the numeric values used for representing pixels, signals, and the frames. So mostly signature files are used for indexing image, video, and audio. But in our case, for textual, the most usual one is the inverted file. So in our next class, we'll try to see the IR models, which takes us to searching. Because the indexing is now complete. We organized our documents by pre-processing and creating the index file. But now the next step is we have to go for searching. To search, we need a model. Because the model should guide us how to search. The searching has to be done systematically and strategically by taking the words, that means index terms, by taking the query terms, it has to compare the two. Towards that, we need a model. So that one we'll discuss next time. We have to communicate because next week there is ለክርስቲያን በተለይ በዓል ነው አይደል? ምናልባት mostly we can think of after a week. That means ሮብ እናደርገውስ? ሮብ እንችላለን? እንችላለን?
next week እስኪ
ማክሰኞና ሰኞ የሚቻል አይመስለኝም። ሮብ ለታ ግን የሆነ ሰዓት ላይ ይችላል ወይ ከጠዋት ወይ ከሰዓት anyway ኮሙኒኬት አደርጋችኋለሁ አሬንጀር
ከጠዋት መሆን ይችላል
ጠዋት
ኦኬ ዶክ ከጠዋት መሆን ይችላል
እሺ በቃ ኔክስት ዊክ ላይ አለን ማለት ነው እስከዛ አሳይመንቶቹን እየሰራችሁ እናመሰግናለን ጥያቄ ያላችሁ ቅድም የሆነ እጅ አይቼ ነበር ላለማቋረጥ ብዬ ነው
ሄሎ አለ ያው አንድ ጥያቄ ሄሎ ኢንዴክስ በመናደርግበት ጊዜ እያንዳንዱን ወርድ ስቲሚንግ ምናምን ከሰራን በኋላ ስቶፕ ወርድ ሪሙቭ ካረግን በኋላ ሁሉንም እንጠቀምበታለን ሁሉንም ወርድ
የቀሩትን ወርዶች በሙሉ እንጠቀማቸዋለን ስቶፕ ወርዱን ካወጣን በኋላ ኖርማላይዝ ካደረግን በኋላ ስቴፕ ካደረግን በኋላ የሚቀሩትን ወርዶች ኢንዴክስ እናደርጋቸዋለን ኤክሰርሳይዙን ስትሰሩት ሞር ኔክስት ዊክ ዲስከስ ማድረግ እንችላለን እዛ አካባቢ ላይ
ኦኬ ቴንክ ዩ
እሺ እናመሰግናለን